Mathematics, Analysis and Approaches, Paper 1, Time Zone 1, HL, May 2025. This is question number 4. He is given as the probability of complement of an event A, and he says it's equal to probability of A union B, and that is equal to 3 by 4. And he also says that the probability of B, given that A has occurred, this is conditional probability, and that's going to be equal to 2 by 3. Given this information, he wants us to find out what is probability of A intersection B. And further, he wants us to prove that A and B are independent to each other. Let's try to do this question very quickly. So what we know is that the probability of A and B is simply going to be equal to probability of A plus probability of B minus probability of A intersection B. Now this is one information that I have with me. And I also know that probability of A is going to be equal to 1 minus probability of A complement. So from here, I can say probability of A is simply equal to 1 by 4. And that is also equal to probability of A union B. And therefore, I can write this as 1 over 4. And therefore, this can be written as 3 over 4 is equal to 1 over 4 plus probability of B minus probability of A intersection B. And this is nothing but 2 by 4, which is a half. And that's going to be equal to probability of B minus probability of A intersection B. I'm going to keep this as the first equation, and then I'm going to look at the other situation here, which is probability of A given that B has occurred is 2 by 3. So probability of B given that A has occurred can also be written as probability of A intersection B divided by probability of A. That would simply tell me that probability of A intersection B is going to be equal to probability of A into probability of B given that A has occurred. And I know the probability of A is 1 by 4. And I also know the probability of B given that A has occurred, which is 2 by 3. And therefore it's going to be 1 by 4 into 2 by 3. And that's going to give me a 1 over 6. That's my probability of A intersection B. So this can be used in the first equation to get probability of A intersection B. So the first equation will now come down to 1 over 2 is equal to probability of B, minus probability of A intersection B, which is 1 over 6. Let me transpose that, and then I'll have probability of B as equal to 1 over 2 plus 1 over 6, and that is simply equal to 4 by 6, which is 2 by 3. That is my probability of B. Right. So I have found A intersection B, which is 1 over 6, and now I have a probability of B, which is 2 by 3. The next question is talking about independence of events. So what do I know about two events which are dependent on each other? It would simply mean that if I'm calculating the probability of A, given that B has happened, then it is not going to be equal to probability of A. Or if I'm looking at probability of B, given that A has occurred, then it's not going to be equal to probability of B. If events are independent, then the probability of occurrence of one of them will not affect the other. And that would mean that probability of A given that B has occurred will be equal to probability of A, and probability of B given that A has occurred will be equal to probability of B. I do know that probability of A given that B has occurred is given by the formula, which is probability of A intersection B divided by probability of B, which means probability of A intersection B can be written as probability of B into probability of A given that B has occurred. Now, since the events are independent, I can write this as that. So I can confirm that the two events are independent only if this situation is satisfied. So let's go back and look at it. What is probability of B? I got the probability of B as 2 by 3. And I know the probability of A. Probability of A was 1 by 4. And you can see that this is giving me a 1 over 6, which is actually equal to probability of A intersection B. Because this condition is satisfied, I can confirm that the two events are independent of each other. That's the solution for this question. Thank you. Goodbye.